Wait a minute. Oh, hello. All right, so we're ready for the fifth and final step in creating our Game of War program. So you should have completed each of the first 4 videos and have that code from each of those functions copied into your main program. So step 1, step 2, step 3, and step 4. Make sure you have those functions copied in. And in this video, we're going to work on creating our main game loop where we're going to actually call and use those functions. Take 2. Okay, so we're ready for the fifth and final installment in our Game of War series of tutorial videos. In this video, we're going to complete the game by writing the code for our main game loop, which is step 5. And make sure that you've copied all of the functions that we created in the first 4 videos from your sandbox into the War Challenge notebook. And this time we're not going to code inside of our sandbox. Since we have all the functions ready, we're going to code inside of the main program here. Okay, so scroll down to the bottom, step 5, where it says create main game loop. And let's go ahead and take a look at the pseudocode we have in there. So inside step 5, we've already got it set up. By default, it has max rounds set equal to 500. And this global variable is going to be used to limit the number of times that the game plays. Since we're writing the game to play until someone runs out of cards, it is often the case that it takes many, many rounds to determine a winner. And so in order to limit the amount of time and resources used playing the game, we're going to limit to a number of rounds, in this case 500. Okay, so the second line here says create the deck and values. I assume that means rank values. I should say rank values by calling the create cards function. And if you remember, and you can look up top, the create cards function returns 2 things. It returns the deck and it returns the rank dictionary. So we're going to use that function to create the global variables that will hold the deck and the rank dictionary like this. Deck, comma, rank equal create cards. Okay, so that will create the deck and the ranks. And then let's go ahead and go to the next step. It says initialize the card piles, player pile, computer pile, and center pile as lists. So let's go ahead and initialize those global variables. Player pile, comma, computer pile, comma, center pile, and set that equal to 3 empty lists, like that. Okay, so that initializes those variables. Now it says initialize the hands by calling the initialize game function. Save the returned results in player hand and computer hand. Okay, so we're going to create our hands using that function. So player hand, comma, computer hand. And we're going to set that equal to the initialize game function. All right, at this point, I'm just going to go ahead and call the code, run the code, and make sure that we don't get any errors. Okay, so there's nothing returned yet because we haven't instructed it to do anything, but we have created some collections. We can just test a few of them, like deck. Yep, we've got a good deck. Rank looks good. Let's see, player pile should be an empty list. Good. Let's see, player hand. There we go. Collection of 26 cards. Okay, so the code seems to be working good so far. Okay, so now we're going to initialize the round counter for the game loop. So we said earlier we're going to limit the game to 500 rounds. So we just need to have a counter so we keep track of how many rounds have been played. So create a variable rounds and set it equal to 0. All right, we're going to here create 2 variables called player count and computer count, and those are going to be variables that we use to monitor to see if someone has won the game. So as soon as either the player or the computer has run out of cards, then the game will be over. But we just need to initialize those variables up front, and let's just start off setting player and computer count equal to the number of cards in their hand. So player count will equal len player hand, and computer count equals len computer hand. Okay, so we're just setting them equal to the length of their hands. And since we haven't played any cards yet, all of the cards must be in the hand at this point. All right, now let's go ahead and create our main game loop. It says the loop will run while both player count and computer count are greater than 0, and as long as the rounds is less than max rounds. Okay, so let's go ahead and write that statement. So since we're using a condition to control the loop, this will be a while loop, right? So it's an indefinite iteration. We don't know how many times it will run. So the while loop is what you use in those situations. So we've got two conditions, and I'm just going to put them into parentheses just for ease of reading and keeping them separate. So while player count is greater than 0 and computer count is greater than 0. That's one condition. So as long as both of the counts are greater than 0, we'll keep playing. And there's a second condition, which is as long as rounds is less than max rounds, colon. Okay, so that's going to be our loop. I'm going to just move this line of code down here below where it says define a loop. Okay. All right, so now it says create an if structure to reset a hand if it is empty. Check both the player hand and computer hand and call the reset hand function if empty. Okay, so if the length of player hand is equal to 0, then we need to reset hand and pass player as the argument. So that will reset the player's hand. And then also if, now we don't use an if else because it's possible in the first turn, in fact, both the player and the computer are going to run out of cards in their hand at the same time. So we need to have these as separate if statements to control that one or both of them could run out of cards in their hand. So if the length of computer hand is equal to 0, then we're going to call the reset hand function and pass computer. Okay, so that handles that. And now the next pseudocode line says call the singleton game function play turn. So we just, since there's no arguments and it doesn't return anything, we just call that function by typing its name in, play turn. Okay. Now it says update player count and computer count by counting the length of both hand and pile. So now cards, since we've played turn, cards are starting to move around. They're starting to be played out of the hands and then into center pile and then ultimately into the player piles. So we need to update the count to reflect that. So player count is going to be equal to the length of player hand plus the length of player pile. And the computer count is the same. It's equal to the length of its hand, computer hand, plus length of computer pile. Okay, so that will update the count to take into account both the hand and the pile. And then we're going to increment the number of rounds by 1. So rounds plus equals 1. All right, so that's our loop. Each time through, it will check to see if a hand needs to be reset. Well, first thing, it checks to see if the game should be played. And it's only played as long as both the player count and computer counts are above 0 and the number of rounds is less than max rounds. And then it will see if any hand needs to be reset. Then it plays a turn, and then it updates the counts, and then increments rounds by 1. So that's the simple game loop. So now we're going to handle what happens when the loop is finished. If the loop is finished, that means the game has completed, right? There must be a winner, and we're going to determine the winner and print out a message. So if player count is greater than computer count, let's print, oops, I should say if. Let's print out a message. Print formatted statement saying you win, you had, and then let's print out the number of cards that the player had remaining. Player count remaining And then let's set the end argument equal to just an empty space. Okay. And then we need an else clause to handle if the computer won. So if it's an else, that means the computer must have won. So we'll say you lose. And then we'll just do the same thing. I'm just going to copy the rest of this print. So we'll just print out how many cards the player had in losing. Okay. And then let's just print one final statement saying, let's make it a formatted statement. Let's say the game took, and then we're going to print out how many rounds it took. Rounds, and we'll call that rounds. Okay, so we printed out a little formatted statement there, and I'm just going to delete this. All right, let's run our code and see what happens. All right, so I printed it out and it played. You can see it's playing each of the hands here. So computer wins, player wins. You can see the action going back and forth. We had some ties. And let's see how many turns this took. So in this case, I won. I had 46 cards. So the computer must have only had 6 cards remaining. But it took the full 500 rounds. Let's go ahead and run that code again and see how many rounds it took the second time. So there, I lost. I had 0 cards remaining. The game took 480 rounds. So you can see that the game of war, the way we've designed it here, can play for quite a few rounds. And many times it will not find a winner in 500 turns. There it took 390 rounds. All right, so that is our completed game of war code. I hope you enjoyed that. So in doing this exercise, this reinforced the concepts of how to define functions, functions that take arguments and that don't take arguments, functions that return values and others that don't. Showed you how to manipulate global variables inside of functions. We covered nested loops and also using comprehensions. So in our create cards, for example, we created different types of collections. So we have, obviously we have strings that we concatenated and used. We had lists that we used for deck and hands, and we had a dictionary for our ranks. I showed you how to split a string and extract a value to look up the index from another collection. We showed you how to have multiple conditions inside of your while loop to control your game code. We reinforced how to create formatted strings to print out, how to use the end argument in your print function. And so hopefully this was a good review of all the concepts learned during Python 1, the key concepts in this introductory Python programming course. Hope you enjoyed it, and we'll see you next time.